Right, well, good morning. Thank you very much for turning up to this session very, very early today. We're going to be covering a session here on managing cold data with SQL Server 2016 and Stretch Database. My name's Sat Pal. I'm a data platform solution architect based with Microsoft in Sydney, and my customers are located within that sort of region. And with me today, we have privilege of Matt joining us from the US. And I don't know, Matt, if you just want to introduce yourself briefly to the audience.
Yeah, hi everyone. I'm Matt Usher. I'm a program manager in the SQL Server organization. I primarily work on Azure SQL Data Warehouse, but I've worked on SQL Server for the last several years. So.
Okay. Before we get started, I like to do just a quick straw poll to see, I guess, what the kind of temperature is in terms of where people are at with the technologies. How many of you have used SQL Server 2016? Okay, good. How many of you have used Stretch Database? Okay, well that's good. You're here at the right session to get some of those insights. And also in terms of your environments today, do you have auditing and compliance requirements that require you to keep data for more than 7 years or 7 years? So in terms of retention? Yeah, okay, good. All right. So, Stretch Database, what is this concept? How do you use it? And what are the kind of key takeaways that you need to learn from today's session? Feel free to ask questions as we go through the presentation. We will also have a Q&A at the end of the session as well, so we can also run the session that way. All right. So, Stretch Database. If I go to the next slide here, we'll start with this piece. So this is something that we introduced with SQL Server 2016, and it was really to help address this scenario of, I guess, compliance and where you've got very, very large data sets and you need to retain those, for the scenario of being able to bring some of those old records back. But having that data set available to you online instead of archiving it off to tape and having it in a kind of like a long-term storage facility. So the idea behind Stretch Database is to give you this ability to park some of that long-term data, that historical data, but having that data available to you online should you need to query that data set, okay? And so typically what you would find is organizations where you have this retention policy for data that needs to have 7 years worth of data for regulation or compliance, being able to meet that requirement straight from the platform with the database engine gives you this capability with Stretch Database. Okay. So my background, I've gone through a number of different roles throughout the course of my career, and one of them was actually a DBA at some point. And I used to work for financial services in London, and we had a very, very strong requirement from the FSA in the UK to actually maintain 7 years worth of data online. Okay. Now, how we actually enabled that online facility was up to us. So typically we would retain about a year's worth in the database environment and then the other 6 years onto tape. Okay. We always hoped that we never had the requirement to restore anything from tape. But sure enough, 2 years into my career, we actually had a situation where we were required by the regulator to actually bring some of that data back, restore it, and be able to query some of those elements. Beyond that time, yeah. So it's quite a nerve-wracking moment when you're asked to do a restore from tape, to bring back some of that historical data back into your production environment, and then allow auditors or the regulators to come in and start querying some of that information. Had we had Stretch Database at that time, that would have been a very stress-free scenario for me, because I could have had that data online, available to me to provide to those external auditors in that scenario. Okay, and so that's typically the kind of use case that you're looking at here for Stretch Database. But there are some other scenarios that I'll talk about that give you some other capabilities here as well, and they may also be useful for your organizations today as well. Now, one of the good things about Stretch Database is because it's embedded directly within the database engine, when you install the product for SQL Server 2016, you can enable this stretch capability on tables that you already have within the database environment. Okay? And as part of that, the end user applications, there's no code change required for them because they still see the table on premise within that environment. Okay? And we're doing the stretch as a background process, and it's completely transparent to the end user applications. So enabling this is actually a very straightforward exercise from your existing SQL 2016 environments. Okay. And the actual migration of those rows, we actually move that to Azure. Okay, so we've got a facility in our platform as a service in Azure to actually move those filtered rows, or the rows that you've selected for those tables for historical archiving purposes, and have them automatically migrated to that target state. Okay? And we'll maintain the relationship between what you have on-premise and what you have in Azure with that stretch database configuration. And that's essentially how this technology works. So this diagram here is really just illustrating that scenario going on. And if we start here in the middle, where we have our existing on-premise SQL Server environment, I could have a very large facts table that maybe contains, let's say, a couple of billion rows of data. And we have this scenario here where we've got hot and cold data paths. Okay? I might be having that situation where I've retained the kind of hot data, which could be the current year's worth of reporting activity, and the cold data might be then, the 6 years that I need to keep for that 7-year history. So in this scenario here, I can apply a filter constraint to this and say, start to migrate that cold data to our Azure destination here, which is our stretch database configuration. Okay? And SQL Server will start to take care of that migration process for us. So I'm not having to build any kind of complex transformation or extract loading routines. It's built into the product. And we'll do a trickle feed of that data out to that target state in Azure. All right? Now, to the end user, whilst that migration is happening, they can still continue to query the table. There's no change to them. Okay? Once that migration's occurred and we've got that full data set in Azure, we have the ability to change the scale, the performance capability of this platform here. Okay? And we can do that on demand. So what I might be doing is running it on a very low performance tier to start with, having that trickle feed happen so that the data migration is going on in the background. Once I've migrated the 6 years worth of data into that environment, let's say we get to an end of year reporting requirement where we're required to actually query that 7 years worth of data in its entire data set and be able to produce some aggregation from that. So what I might choose to do at that stage is actually increase the performance tier of that Azure environment, okay? And say, for this period, when we're going to do this end of year reporting, let's scale out the architecture for that. And so we run it on a higher compute configuration, and then be able to return the results of that 7-year query in a much shorter time frame. Okay? And so it's not only the archiving piece here, but also this elastic capability that we have in the cloud environment that we can leverage now as part of the stretch database configuration. Okay? So now it starts to open up other possibilities on top of just standard sort of archiving. Okay? We started off with the archiving as our requirement, but now we actually have the ability to offload large amounts of compute. Okay? The other advantage of having this type of stretch database configuration is if I'm dealing with a table on-premise that's currently billions of rows of data, there's a storage requirement for that in terms of my on-premise requirement. Okay? If I was to maintain that fully within my data center. By having the stretch database configuration, because I've moved a large proportion of that data out into the cloud, I now have a much smaller footprint requirement for storage on-prem. Okay? And so, I start to free up resources and allow my application to grow and be able to retain larger volumes of data using the same infrastructure that I've already invested in on-prem. All right? And that's a really nice capability here in this setup. Because that footprint is much smaller on-premise, it means things like backups are a lot smaller as well. Okay? So when I'm backing up the data on-premise, it's actually only the hot data that I'm backing up now as part of the database. I had a customer scenario recently where one of their tables was 11.3 billion rows of data, and it was a 300 gig table in one SQL Server environment. Okay? And that was one of their fact tables. They had another fact table of equivalent size. And that was only 4 years worth of data, and they said, we actually want to keep 12 years worth in this environment. Right? So you start to imagine that scenario then folding out, and you say, well, how are you going to provide the storage for this? How are you going to manage to do the querying at scale? Running on an SMP architecture. So this was a single virtual machine with about 16 cores, 96 gigs of RAM, and some SSDs backing up that, providing that storage capability. But they were going to very quickly run out of capacity, not only from a compute perspective, but also storage. Okay? So stretch database in their scenario was actually a very, very useful capability, because they didn't actually need to query that 4 years worth of data continuously. They only really needed the last year, but they needed to retain the other data for compliance and regulation. All right. So in that instance, stretch database was actually a really good solution for them to kind of place that data in two places, but from an application perspective, provide only a single kind of view or entry point into that. Okay. All right, so there's a little bit more here about the actual migration process. Now, I've already talked about this trickle migration. There's actually a couple of advisors that are built into the product today that allow you to, first of all, identify candidate tables that you could use for stretch database, and we'll actually go ahead and we'll advise you what are the tables that have the right kind of data sets and potentially no incompatibilities in terms of features, and we'll say these are good tables that you could potentially migrate and have running with the stretch database configuration. And as part of that, we'll also then allow you to then initiate that process, and SQL Server will then really carry out this trickle feed scenario. Now this is designed to be very, very lightweight and low impact to the system, which is why it's an online operation, and you can do that whilst you've still got workload running in the database environment. Okay. The other enhancement around this is how the query processor works once you stretch a table. So one of the challenges you have now is you've got data that's sitting in the cloud and you've got data that's on-premise. So how does the query optimizer understand where that data is located? Well, as part of that stretch database configuration, we'll store some metadata within the SQL environment, and it's able to assess which parts of the data live on-prem and which parts live in the cloud, and how to offload some of that compute. Okay? So if I'm running a large aggregate query and I'm going to be touching billions of rows of data in the cold data set, the optimizer will send those relevant instructions to this cloud environment here on the right-hand side and say, hey, can you generate me the aggregate output from that? And so I can combine it then with the result set that I have locally on-prem. Okay? So those smarts have been built in to make this process as kind of frictionless and as seamless as possible, okay, as a technology. Okay, so these are some of the things that I've already talked about. So the typical sort of requirements for stretch database or key considerations in terms of what tables you enable stretch database for. Usually it's this one here in the middle, where you already have a very strong requirement to retain several years worth of data. Potentially you're resource constrained, and you can see that the data volumes are continuing to increase in your environment. So you're looking for smart ways to manage those large data sets as your environments continue to grow. Okay? And so that's usually the thing that drives a lot of this initially, but it doesn't necessarily have to be just that. And the offloading of compute is the other example that I've just given you there. So this one down here, the offloading of compute, so that's that scenario where you've got the billions of rows of data, but you want to leverage some of the compute capabilities in the cloud combined with your on-premise data sets. Okay, so that's that scenario that Stretch Database also helps address. And then the top one really here is around that storage. Okay, so a lot of organizations now are investing in high performance storage, dedicated performance tiers for tier 1 applications. And so if you're doing a lot of that and you're challenged with capacity going forwards, especially with data volume growth, then Stretch Database could be a nice way to kind of give you that blended story. So you've got your high performance storage for your hot data, and you're able to give that really good end user reporting experience. Plus you've retained the large data in an online capacity with Stretch Database. Okay, now there's a couple of other things that you need to think about when you're switching this feature on. This second point here around infrequently queried large historical tables. So if you've got a data warehouse environment where you're running analytics in a real-time scenario, then Stretch Database is probably not the ideal candidate for that, okay? Because otherwise you're going to be constantly running those kind of queries across your on-premise and your Stretch Database environment. If you're dealing with that type of scenario, then you might be better off moving the entire workload to the cloud. okay, and just benefiting from that extended, elastic kind of compute architecture from the ground up, and maybe not have stretch for that. The other scenario here, actually, where it can be good is sometimes you've got applications where you're feeding in transactional information to your hot data. So you're putting in lots of new information in your hot data path. But you've got a process that requires you to do some sort of reconciliation against those transactions coming through. So there might be financial transactions, but they need to be validated against a much broader set of historical transaction data. So in that scenario, you could use this hybrid architecture between the hot and the cold data to do some of that reconciliation process as well. So these scenarios could work, but again, you'd have to really test your particular workload to make sure it's suitable for that scenario. Okay. And I've already talked here about the database size. So this is another challenge that some of our customers have, is when you get to that kind of multi-terabyte on-premise database environment, the maintenance window that you need to do your backups sometimes starts to impact your production processes, right? So you have this finite time, usually overnight, where you've got to get all of your maintenance activities done before the start of business day. Now, if it's taking you 7 or 8 hours to do a full database backup overnight, and it starts to encroach on the start of business day, then that's not really a great experience, right? So Stretch Database will help with that scenario as well, because you're only backing up the hot data. Okay. All right, so a couple of other things here. Always encrypted and row-level security. Is anyone using any of those two features today in SQL 16? No hands? Okay. So these two components are something that we introduced again with SQL Server 2016 as ways to enhance the security within the database engine. Both of those components are fully compatible with Stretch Database. So if I'm looking to host or if I'm looking to kind of have some of those historical records moved to an Azure environment via Stretch Database, I could have an always encrypted data set and maintain that encrypted data set in the cloud. All right. So in terms of security and compliance, especially where you've got sensitive information, you can maintain that security layer from your on-premise environment and have that extended out to the cloud. All right. So these two features work really well in that scenario. You also have the ability down here to pause and resume the actual Stretch Database service. So sometimes there are scenarios when you're doing maintenance on the data itself. Maybe you're going to be loading a bunch of new records, or you're doing some updates that are going to impact several billions of rows. And so what you might want to do is pause any of that kind of archiving process for a Stretch Database whilst you perform that data maintenance task. Okay. Other times you might have a genuine outage, or you might have genuine scenarios where you're doing other bits and pieces within your on-premise environment that require you to kind of pause that communication with Stretch Database, and you can do that anytime. Okay, so that's also another feature that's built in. I've been talking about backups on-prem, but I'm surprised actually nobody's asked me about the backups in Azure. So once you create a Stretch Database configuration, we'll take care of the backups for that environment for you. Okay, so if I've migrated several hundred terabytes worth of data as part of my Stretch Database configuration, I actually don't have to worry about how the backups are being done for that, because that's part of the kind of service tier that we offer when you set up a Stretch Database configuration. Okay, so that's built into the product. So the only bit that I need to worry about is backing up the data that I have on-prem. I should have an operational process around that anyway today. Okay. All right, so Stretch Database Advisor is the kind of built-in wizard that we have with the product that allows you to do this assessment. So if you've got an environment today where you've got lots and lots of very large tables, but you're not sure which ones are good candidates for Stretch Database, spinning up this advisor and just getting it to do an assessment is a really good way to get started with this, okay? And it might be that maybe out of a list of 10 tables that it suggests, maybe there's only 2 or 3 that you really want to enable this capability for. And we're also bringing this capability to the data migration assistant as well, so that's a kind of another... It'd have to be 2016. It'd have to be 2016, yeah. Good question, though, yeah. And so the other thing that you need, obviously, is an Azure subscription. Okay, so in terms of requirements, as long as you've got SQL 16, You could use a database, the Stretch Database Advisor, to give you a list initially of what tables to move or migrate, and then you'll need to have your subscription set up as well.
Is it in all versions or only Enterprise?
All editions now with SQL Server 2016 with Service Pack 1. Service Pack 1. So actually that was a significant change with Service Pack 1 for SQL. Not only did we put product enhancements, but also there's new feature capability as well. And it's actually enabling those capabilities throughout the editions of SQL.
With the 2016, if I've got requirements to keep it on premise, can you have, say, one first instance and then, say, a second instance on premise instead of Stretch?
Not at this stage. Yeah, it's only to Azure at this stage. Well, one of the reasons is because of the volume of data that we're anticipating, right? So if you're doing a stretch, we're expecting billions of rows of data or hundreds of millions of rows of data, potentially in the terabytes beyond. If you wanted to do that type of configuration, there are other ways that you could maybe manage that. SQL replication could be one of those. It depends what you're doing with that kind of archival data, I guess, on premise.
Yeah, just sort of value in that sort of your query still hit one point and it's initial by itself.
Yeah.
Migration.
Yeah.
Great.
Yeah.
I do have a question more around restoration. So if you've got two separate databases, you back up one on a regular schedule, the alignment of data, which is shifting stuff out,
Yeah.
is that handled?
Yeah, great question. So the question's around how do you manage the database restore scenario on premise, I'm guessing?
Yes.
Yeah,
in
so
line
with the stretch. So if you've got a stretch database configuration and I'm doing backups and these backups are happening independently, and then I've got a requirement to do a restore at a point in time, what happens is when you do the standard database backup, SQL is aware of the stretch database configuration, and it's aware of the point in time when it was able to kind of time slice both scenarios, both environments. So it knows how much has been synchronized and what's still outstanding. When you do the restore, after the restore is completed, we'll do a validation check to make sure that we're at the same point. Okay, so we'll take care of the transactional consistency as part of that backup and restore process. Yeah.
So if you've got to go back a number of days
Mm-hmm.
because of an application error, would it actually then, say if you've got to restore like 2 or 3 days prior rather than just before corruption, would it?
It will still attempt to reconcile those records, but what it.
You know, double the amount of data, you know, days in the original database you just restore, and you have the same data in the stretch database.
Yeah. It will reconcile between those two scenarios as well. Yeah, because we have to guarantee whatever you've applied in terms of filtering and archiving, we need to maintain that state wherever you land in your on-premise environment. As long as the configuration for that stretch database remains the same, that's a workable scenario there as well.
Does that include if you restore to a separate database?
Yes. So you can actually migrate. So let's say, for example, if I've got server A on-premise and the hardware for that needs a refresh, so I migrate to a brand new environment, I can re-establish the stretch database relationship with that new environment. So you can do that migration as well.
Is it possible to move your data back on premises easily enough?
Yes. Well, okay. So there's a two-part answer to this, right? So yes, you can disable stretch database. Yes, you can bring the data back on-prem. Is it an easy thing to do? Probably not, right? And it's going to be volume of data that's going to be the issue. So if I've migrated 2 terabytes worth of data off to the cloud, and then I say, right, actually I want to turn this whole thing off, right, now you're going to have to wait until that 2 terabytes worth of information comes back on-prem.
Trickle it back?
It is kind of like a trickle feedback. So it could take for quite a long time to bring it back, which is an important consideration. So if you are turning this thing on, the idea is that you've done that planning up front where if you're just testing it initially, then obviously you try it with a very small data set. But once you implement it for a production scenario, you've made a conscious decision about that as a design for your hybrid configuration. So bringing it back on-prem, it's a bit like once you've backed something up onto tape, right, and then bringing it back again. You can do it. It's going to take a long time, and it's probably going to hurt you a little bit, in the process. Question at the back.
How are schema changes managed
Yeah, look, that's a great question. So if you're, let's say, for example, if you're modifying the width of an existing column, it could have a significant impact, not only on-prem in terms of how long it takes to apply there, but also what does that time look like in terms of application in Azure as well?
The short answer is it depends on the scale of the Azure side. So if you have a very small scale set on the Azure side, it will take longer. If you have a much larger scale set on the Azure side, it will take much more efficiently. Yeah. It's truly, you have compute in both places, and so if you're running a laptop size edition basically in the cloud, it will take a while. If you run a giant instance in the cloud, it will take faster. It's the same as it would on-premise.
And just like the scenario where I mentioned earlier, where you can offload large compute requirements to the cloud, if you know up front you're about to do something like that in terms of maintenance to the schema, then scale up the environment in Azure first, right? So give it some more capability before you carry out that type of maintenance activity, just to reduce the time.
And it's sorry, go ahead.
Can you split the scope? Can you do your on-prem schema update and then 2 days later do the...
No, it's transactional consistency, so it'll do it as one operation. One other thing too is this is a scale of data operation, so the larger data set you have, the longer it will take. So.
I have got an Azure SQL Server 2016 and SQL Database 2016. Can I do just database like linked server?
So you've got an Azure Data Warehouse, and you've got a SQL Azure DB, or
Azure DB.
Yeah, so the Azure DB, the PaaS service, currently doesn't have stretched database capability. So it would have to be an IaaS environment, infrastructure as a service. So a traditional SQL Server instance where you can turn this on. But I don't know, Matt, is that a good feature that we could potentially put in as a migration path or a...
It's an interesting scenario. We don't have it today. SQLDB doesn't offer this capability. SQLDB is currently limited to the larger sizes of 1 terabyte for full database size. Even with column stores, I mean, you could push 3-4 terabytes in one of the larger P instances, but generally customers don't. In the cloud, the model's set up a little different. Stretch is more targeted at scenarios where I've got a operational data warehouse or operational database sitting on my environment. I'm paying a bunch of money for storage because storage is expensive on premise. I mean, go to the cloud and you look at things, and I mean, Microsoft, Amazon, Google, we're all racing to see who can give you the most storage away for free. I mean, that's the race. It's a race to zero, right? It's a zero-sum game. So when we talk about this feature, it's more about that scenario. In the cloud, kind of the dynamics are much different. Generally, we have things like elastic pools where people are splitting things across pools for scale out. So what people do with the systems in the cloud is a little different. I'm curious about your scenario, so if you wouldn't mind hanging out afterwards, I'm curious to hear what your scenario actually is.
Yep.
Do you have any limitations on data types?
Any limitations on data types? Yeah, so there are things like, I think XML right now isn't supported. JSON data types aren't supported. So yes, there are a couple of data types where those constraints. Running the advisor, though, will highlight those. Okay, and that's the easiest way to assess. I think there was one question at the back first, quickly.
How does it work in all these own scenarios without...
It just works. It just works. Yeah, that's the short answer. And I've tested it in previous demos as well, and it's brilliant. It just the key thing is you need to make sure that the key that you set up. So we look at encrypting that data before as it's landing in the Azure environment. There's a key that you would set up as part of that configuration on premise first. So as long as that key is available on the secondary, that's all you need. So when the failover occurs, everything just continues on. And the always-on configuration is aware of that setup to stretch database. Yeah. So yeah.
You have to remember that this is all done in the SQL engine process itself. So even on the read secondaries, like in an always-on scenario, the read secondaries are aware of the same configuration. It has the same metadata information. It has an identifier. This is a stretch table, and it has the details on where to go get the data. So the cloud service itself can serve multiple, a single read master with multiple, a single write master with multiple read secondaries. Yeah. And the cloud can support that easily.
And including the reconciliation as well. So once the failover occurs, just making sure we're established at the same point in time again with that sync. Yeah. I'll take one more question, then we'll continue with the slides. Good questions though.
Migration from
Because it's an infrastructure as a service, so it's an instance of SQL that's sitting on premise, your migration path would be to establish another instance of SQL in Azure. One of the ways that you might want to do that is create a hybrid always-on configuration. So you have an always-on primary on-premise, and then you create an always-on secondary in Azure. Get those two synchronizing the hot data whilst your stretch database is running this way. And then when you're ready, fail over to your always-on secondary in Azure. And that will provide you a nice clean way to do that hot data migration to Azure as well.
And this path too, like, if you think you've got SQL Server on-premise, it's installed on a server under your desk, hopefully not, but you know, it happens. So you're running SQL in your environment and you want to move to the cloud. You really have a couple options. The option that Septal was talking about is the move from just infrastructure on-premise to infrastructure in the cloud. You can go light up an IaaS VM, whatever size you want. I'll be running one here in just a minute. You can see it. It's just a VM running SQL with Windows pre-configured on it and a specific set of resources attached to it. And that's a very simple migration. A lot of people do that. It gets you out of hosting your own data center and infrastructure and just lets Microsoft take care of that. And then you just have patching requirements on the VM. And then the second step would be obviously naturally moving into a PaaS service where you're not even managing the VM, where it's Azure SQL Database, where it's just a fully managed environment. And that's a second step. There's options on how to do that. There's a bunch of tools that will take you from on-premise to the cloud. I mean, it's not this session, but there's definitely tools. You can just go in and say, I want to take this database and make it a SQL database, and it'll just happen. Yeah. So there's all kinds of options for that.
Okay, good questions. I think we'll carry on a little bit in the sort of a sense of time, and we'll bring up Matt now to do the demo. So enough talking from me, and you actually get to see some of this stuff working.
All right. So we'll switch over. And the way this demo is set, it's kind of a combination of things. And so what it's going to do is it's going to show you a combination of the SQL Server 16 features. Oops. We'll make sure we get that down. So the way this demo is set up is, this demo is set up to show a lot of SQL 16 capability. So the setup to this is, imagine that you're running a travel services and somebody calls in and says, hey, I'd like to book a flight with you. That's kind of the scenario here. And the idea is to show you a lot of these capabilities that SQL 16 has. So things like always encrypted, so you can see data encrypted. You can see stretch running to the cloud. We'll show temporal data. So how many of you know what the temporal system is in 16? Okay. So I'll give you a little history of that before I actually show it to you. So temporal data is the idea. It was introduced in ANSI 2001. And the idea is that you can take a table, and the system will automatically generate a historical version of that. So every time you make a change to the table, we essentially store that change in a secondary table. And at any point in time, you can go query that. So you can say, oh, what was the state of, say, the employees table 2 years ago? So what did my company look like 2 years ago as compared to now? And you can query both of those kind of straight from SQL. And so that's another one of these capabilities. All of these features that we were talking about, so always on, row-level security, dynamic data masking, all of those capabilities work across all of these scenarios. So for Stretch specifically, being able to take all of those features you built in SQL 16 and then just take all that data to the cloud, or whatever set of data that you have to the cloud, is just something that should happen as a natural transition. So I'll walk you through, this is a pre-stacked demo of kind of showing you some of these capabilities. And so the narrative will start as, I'm the sales agent logging in. And so I have this dashboard. And this is just a contrived dashboard. This is connected from my local machine here, actually connected up to an Azure VM running SQL Server 16. My local machine here is not very powerful. So this is connected to a back end. And the scenario is I have a customer who's called me or emailed me and said, hey, I need to take a flight. And so I'm going to go book that flight for him. And we're going to show you some details about that. So the first thing we're going to do is we're just going to do a simple context search for the customer. So in this case, it's Jamie. And I'm going to click on Jamie so I can get kind of the back end historical information. Now, this is an Angular setup. And so what it did is it's actually live going out and querying the database. So every time I typed, it was actually querying very quickly. So this is from my laptop to the cloud. Surprisingly, it's actually pretty fast. Connectivity here isn't too bad. So the VM is actually hosted here in Australia. So it does kind of work pretty quickly. But it does, in this case, it's connectivity from my laptop. I'm going to pick where this person's going. So I'm going to happen to pick Arizona here. They're going to leave Arizona, and they're going to fly to Quebec in Canada. So we'll kind of scroll through. And this is what an application you would expect, right? This is traditional kind of operational, dashboard that I'm working with, kind of interacting with the SQL database. And then I'm going to pick a date. So let's say next Friday. And I'm going to go flying some flights. Now the query here, again, this is nothing fancy. It's just a SQL query out to the cloud, ran my query, and came back. And it showed me a set of flights. I'm going to focus on these first 2 flights here. So this first one, and the way these columns are set up, kind of the 2 key columns to look for are the price column. So this one seems to be a little cheaper, and this reliability column. And that reliability tells me how often did that flight take off on time. How often did it land on time? So we're really trying to find a good flight for my customer that's cheap, that's going to get there kind of on when they expect it to. So we don't want them to show up 5 days later. And so we can kind of look at this. Now here's where some of these other SQL Server capabilities come in. So this kind of looks like, if I'm comparing, say, just these first 2 flights, the second one's a little more expensive, but it seems to be a little more reliable. So, okay. But as an end user, I don't know what that reliability means. Is that reliability this week, this month, this year, forever? What does that mean? So I can go look and say, maybe I'm going, well, or maybe we know something about the airline. Maybe the airline has all of a sudden improved quality in the last, say, 6 months. Maybe they got bought and are now better airlines than they ever used to be. So I'm going to go down here and I'm going to look at the history. And we're going to say, take the history from the beginning of the year, and we'll look through to today. And so what this system just did is it ran a temporal query. And now I'm going to explain how this all works in just a minute. And what it did is it said, go find me the historical average of that flight in percentage, and show me the variance against what my current estimate is. So looking at the difference between the 59% and the 65%. So what we see is that over the first part of this year, so year to date, the flight's actually much more reliable than it has been in the past. So as an end user, I'm able to do this very quickly, in this case visualize, by using that temporal data. So every time we've tracked this flight taking off and landing, we're able to see how that flight can be based, not looking at what's the current state, so what's the current 59%, but using whatever time range I wanted. And so I'm able to go through and evaluate what that flight is. And in this case, it gives the end user, in this case me, trying to offer a flight to my customer, some information. So that looks like a pretty reliable flight. We'll do the same thing by looking at this second query, or the second airlines. And you can see, even though it seems that their reliability is pretty good, maybe that was 6 years ago. Now it seems that this year they're having some problems for whatever reason. So maybe I don't want to book my customer on that flying. Now I'm going to switch over to the VM here, and I'm going to show you how this actually works. So this is that VM running in the Azure cloud. And this is what is called the monitoring view for stretch. And I'm going to point out some things. I'm going to kind of point here a little bit. So this is the actual table that we're looking at, this DBO flight feed ETD table. And you'll see underneath it that there's actually a subtable. And you'll see the markers for system version and history. This is a temporal component. And what it's telling you is that every time I do an interaction with that table, so an insert, an update, a delete, a bulk insert, any kind of interaction, it automatically logs it into this history table. It's done completely system managed. So you as an end user just set it up, and it starts running this. And it means that I can go query both of those things. I can query the current state of the table, just like you would anything else, select star from table. Or I can actually run a particular query that shows me select star from the history. And that's actually what that system you're seeing was doing. And so I'm going to show you what that syntax looks like. So in this case, you can see there's this new kind of indication. And what's interesting is it's straight SQL statement like you would write anywhere else. But the new syntax is this for system time as of. And you can go pick a particular date. You can pick ranges. You can get the data based on those different ranges. And what this means is now not only can I look at the live state of the table, I can look at the historical state of the table. And so if I run this query, it'll take a few seconds here. If I run this query, what's going to happen is the system's actually going to go out and look at the history of that flight. And this one, I happen to pick that same flight in June of last year. And you can see that that year-to-date end is actually a different value. And so you can see that over time, the historical state, we went from 69% to what's now 59%. So something's happened. And we can go monitor and view that data at any point in time. You can see it's just a simple SQL query. And this gives you the ability to kind of look at the data over time. So this is one of those SQL 16 capabilities. And now how this relates to stretch, I'll get to in just a second. So if you see that this table here itself is actually stretched, and I'm going to zoom this a little bit, if I can. Hold on, let me get zoom it open. Zoom it's not on this machine. So it's a little hard to see. But what you can see here is we're actually looking at these tables, and I'm going to pick the first one here. These have been pre-configured. So you can see that historical table. You can imagine that in some operational system like selling airline tickets, a table could get pretty big pretty fast, that historical table. And in this case, you can actually see that it's been stretched, the number of rows that are currently possible to be stretched, based on, in this case, this is fully stretching a table. So we're saying just take the whole history table and shove it in the cloud immediately. You can see how many rows are local to the instance and how many are sitting in the Azure cloud. And so in this case, you can see we pushed all of the rows into the cloud. And as we were talking about earlier, this can be done based on a predicate. So you could say, in this case, I just want every row for this historical table to move immediately to the cloud. Or you can do it on any kind of predicate you'd like. So you could say where the data is older than 90 days. And so you'll start to see data trickle into the cloud based on that running date range. The SQL engine itself will handle that. So as the date time clicks, say tomorrow, then data that's 91 days old will start to move into the cloud automatically. It just trickles on its own. So as an end user or a developer or as an applications manager, you don't actually have to sit and manage, okay, what data has to move today. This is all done by the SQL engine itself. Now if we go back and look at the results here, when I pulled this, because this table's been stretched, specifically the history table, this data came from the cloud. There's no data, as you saw in that rows of local, 0, no data sitting on this SQL instance. It reached out to the cloud, ran a computed query there, pulled the results back, and displayed it here in front of you in SSMS. So I was able to do that by simply running a query, which looks like and interacts like any other query. I didn't have to tell it, oh, go connect to this cloud instance or any of that. Excuse me. It just works. And it takes that capability of just shoving things into the cloud very, very quickly. So now let's go pick this flight, since we've decided that this is the flight we want to offer to our customer. And we're going to purchase the flight. And I'm just going to pick, say, her MasterCard that we have on file, and I'm going to process this. And so this will create a transactional record. And so you can see I've now purchased the flight. And also in the way this system shows me, I have all of her purchase history. So I can go look at all the past flights that this person's take or purchased through our travel agency. Now, what's interesting about that is if we go back to our VM and we go look at the monitoring, you'll see that there's this transactions row. That actually happened. I have to refresh the screen here in just a second. So you'll see things like activity history and transactions. And so those are the two things that you're seeing on that screen. The transactions are obviously the purchase that we just made. And you can see it took a second to refresh. You'll see that that row just showed up. So now I have a local row that's indicated on my local machine that will eventually leak itself to the cloud. And so this will eventually, in a few minutes, actually leak itself right up to the cloud. As an applications developer, I don't have to think about that. I just wrote an insert into table kind of constraint or statement, and all of a sudden SQL's now taking care of all of this history for me. Now what's also interesting is we've now parsed this activity history table. We've said we only want to keep hot data local, so things maybe in the last 90 days, and anything beyond that we're going to move to the cloud. And so this is an interesting kind of hybrid scenario. So maybe you do want to keep some of that data locally. You want to keep it so that you have very fast access to it. But in cases where you need to get access to the data over a period of time, you can. So if we go back and look, the way that this table is set up is we've said, take anything that's older than 2014 as a record and push it to the cloud. Everything else keep locally. And so when this application runs this query that says, go get all my history, we can see these first few set of rows, they're coming from the local instance. They're all 2016, 2015, or the one we just created here in 2017. But if I happen to scroll down, you'll see these 2014 queries all coming in. 2013's. Well, these rows are coming from the cloud. And as an application developer, I just did select star from table where, and I was able to pull all this data. And I didn't have to do anything from a development standpoint. So I can take my application that's already existing, and I can stretch pieces of it with all of these new capabilities without impacting front-end code. It makes the application migration experience very, very simple. It's truly just an administrative operation. You don't have to impact any other part of your business to take advantage of this. So if we go look at how that happens, again, those are these two tables that we're kind of interacting with here, this activity log table and this history table, so this transactions table. You can see that that data is kind of hybrid mixed. And if we go back here and we want to run another query, we can go look from all of those transactions where my customer ID is this happens to be that customer. And you can see that if I run this query, now this will take a few seconds. What the SQL engine doing right now is it's actually generating two plans. It's generating a local plan against the rows that it has currently in the local system. And it's just generated a cloud-based plan that sends it out to the cloud, runs a distributed plan query execution in the cloud, takes those results, pulls them back to the local machine, merges them with its own local results, and then displays them to you here in front. And so it did that in just a couple of seconds. It took about 12 seconds to get these 35 rows. And what's interesting is that now you can see other capabilities. So pretty straightforward columns. We have a customer ID and transaction ID, date, and then all of a sudden we start to get these hex-based numbers. And this is the capability of always encrypting. And so the capability of always encrypting in SQL 16 is the ability to take a SQL Server column or set of columns and be able to encrypt that on the client side. This is especially interesting when we start to talk about cloud-based scenarios where there's concerns about security. So if you see something like card type and card number, these are fully encrypted. And the way the system works is given a local .NET driver, ODBC driver, you can set the encryption certificate and library on the client. And as the data is transmitted, it's encrypted on the client and sent to SQL as an encrypted hash, just like you see here. SQL Server itself, and in this case it's an ISVM or SQL Database as a Service or SQL 16 running on-premise, will only have the encrypted version of your data. Now there's a bad side to that. You can only do like operations. We can't do, or equivalency operations. You can't do like-based operations. But once you have that data encrypted, then the instance itself is completely secure. You could take this data itself, take it off the cloud, take it out of IaaS instances, restore it somewhere else, and there's no way for you to unencrypt this data because the certificate is held by the client itself. It's not actually in the running service. Now, on the backside of this, if we went back through the operation, well, what if I actually want to see this data? Again, this data is transmitted then, say, in a select statement, out to the client, and the client can decrypt it, again, using the same libraries. It's just a capability of encrypting a column. And so this is pretty much the way that the SQL instance works. Now, you can see that I took all of that data that's sitting locally in this VM, and I took data that's now sitting in the stretched instance, I merged it back, and I didn't have to change a single thing in my application. And the last thing I'm going to show you is how we actually did this. So I'm not going to fully walk through the entire scenario of a wizard, but I'm going to walk you through kind of the basic ways. So the first thing that we'd have to do to enable this in SQL 16 is we would start at the database and in tasks, and you would see this new option for stretch. Now in this case, it's already been done for me, so I could simply enable this. When you enable it, it'll ask you all of your information about your Azure instance. So give me your Azure credentials to start to be able to log in. What subscription would you like to use? Would you like to create a new server? Would you like to use an existing one if you have one? And you can be able to point multiple databases at a single instance, single logical server in the cloud. Now, how many of you have an Azure instance of DB or DW? Okay. So for the rest of you who don't, we have this concept of a logical server in the cloud. It's just an endpoint. It doesn't actually physically exist. When we think about a physical server, most of the logical instance in a cloud was built on the concept of we didn't want to change all the tools. So when you connect with, say, SSMS, you say, here's the data server I want to connect to, and then here's the actual database. In the cloud, we have that same concept. So you would be able to say, oh, I want to target multiple stretch instances to a single logical server. They're not physical. They're all isolated from each other in the cloud, but they're just kind of grouped as a folder container, if you want to think of it that way. So you'd first go enable it. And again, you can see the monitor tab, which is this view that we were looking at here. And then you can pick a table. So I'm going to look at something like pay history. And you can simply right-click on it, stretch, and enable. And then this will start a sequence of enabling a wizard that will walk you through the process of taking that table and moving it to the cloud. So I'll walk through a couple of these screens. I'm not going to fully go through it. So it'll ask you, is this what I want to do? You can see what I want to, if I want to migrate it. In this case, I can say a complete table, or I could take something like what kind of column, I could set values, I could set all kinds of configurations. So I could say, oh, I only want to take, say, employee history with names that start with, say, M. So take all the mats and put them in the cloud. Or you can put whatever predicates you want around how you want to stretch your table. So you have complete control of defining that configuration. In this case, I'll do just the entire table. I hit the wrong key here. We'll try that again. And then we already have in this case, we already have the definitions already set up. In this case, because I had stretched this already, I didn't get prompted for that. So you can see that I have a source server name, and that's this physical machine. It has a stretched database demo, so the database name. And then in this case, it will, if you don't have one already set, it'll ask for a database master key to encrypt the data on the fly. So this is how we make sure that all of the data that you have locally and some of the metadata that gets passed back and forth is encrypted using that key. And we use the key locally instead of in the cloud to be able to push that information back and forth. Because again, the master of all of this is the local instance. And so once you do this, then it really is simply this fast. If I click finish here, so the configuration is done. And what's happening now is that that table is now starting to be stretched. And so SQL Server will take over. As a user, you don't have to worry about what's now happening. In a few minutes, this screen will refresh. Auto-fresh turned off. In just a few seconds, this screen will refresh. And what will end up happening is the view of this will show that there's a new table here, and you'll see the rows start to move, and you can monitor from here. So you're able to see that the data starts to move. Now, during that trickling operation, each time we move a row, it's metadata marked and journaled so that if SQL Server runs a query, it'll know, the very first row, I only have one row in the cloud. And if I'm excluding that row by some predicate, it'll actually not send a distributed query to the cloud. So it knows the difference of where your data is. So it's a smart system in that sense. And as your data starts to trickle, you can see the data starting to trickle here. In this case, it doesn't actually have any rows in this table. That's why I picked this one, because it'll just be a quick demo. But the table would start to transition. So you would see I have a source set of eligible rows, I have how many local rows, and you would see these numbers start to adjust as the data starts to trickle into the cloud. And it means that you can do this as a DBA level operation. I don't have to worry about, okay, let me call my developers, let them know I'm going to have an outage. The system does all of this online. And so as this data is moving, your application just runs. Yeah?
So what happens to all the database statistics on premises?
So the question is, what happens to all the database statistics on premises? They don't change. So the statistics, from a SQL perspective, this is the storage change. So the data just happens to live in multiple locations now. But the metadata of the table itself isn't any different. So if you run an update stats on this, it'll run it across all. Or if you do something like 10% stats update, it'll pick both local and cloud. So all of your data, just like it would. From it's kind of hard to describe, but essentially there's a split level. There's the view of the table in entirety that SQL, the engine itself, just operates on. So statistics, indexes, DML operations, those kinds of things. It looks at the table in entirety. And then there's this operation, which is kind of lower level, which is saying, okay, well, how do I lay that down in my environment? And in this case, it's saying I want to leave some on-premise and some in the cloud, or move it all in the cloud. But from a SQL engine perspective, the table presents itself just like any other. You can do anything you want with it, joins, permission, all of that kind of stuff. Same with things like row-level security. So if we happen to have a table that has row-level security, and say I happen to not have access to this customer's data, that's respected in the cloud. So as the data is transitioned to the cloud, if there's a row that I shouldn't see even in the cloud, it'll be excluded in that query operation across. Does that make sense? Yeah.
How it works with partition tables? So imagine I have a table which is already partitioned.
Yeah.
Then I need just one partition to the cloud, or stretch with one partition, or I have to do that for a whole table.
So the question is, I'm repeating for the audio. So the question is, if the table's partitioned, can you stretch a partition, or is it stretched by just a predicate, essentially? Is that your question? Okay, yeah, so the answer is it's stretched by a predicate. So generally partitions are done by dates. That's the most common pattern. I see people using partitions. People do other things, but generally it's by dates. And so oftentimes the predicates that you use for stretch will also follow that pattern. So you could say, stretch everything over the 90 days, and if you have a partition that's kind of split, some of that data would be local and some would be in the cloud, stretch will handle that for you.
And the other way you could do that is you could have a temporal table there as well.
Yeah.
And so so you've got your partition table, but then you create a temporal table for anything that you want to archive, but keep online. And then stretch the temporal table in its entirety. And so that gives you that kind of nice way to kind of archive that data in an automated way.
Yeah.
What happens if you disable your stretch database? Now you enable it.
Mm-hmm.
What happens if you disable?
Uh, the act,
Will the database shift from your Azure back into your local?
Yeah, so the question is, what happens if I disable? So it'll do exactly that. So in this case, you can see, I don't know, I'll do the math off the top of my head, a couple million rows, 2.5 million rows. So what will happen is exactly the opposite of the trickle feed to the cloud, is it'll start to leak the data, the rows from the cloud local, and as soon as it's done, it'll go turn off the cloud instance.
There's an option there, though, to say if you didn't want to do that, because there are some scenarios where, let's say if you're working with a temporal table and you consciously archive a whole bunch of data and you never want to bring it on-premise again, but you want to retain it, and rather than have it on tape, you've got it online. You can, when you say disable, you can say leave the data where it is.
Yeah.
So you can decouple it as well, and that's an option. The other nice thing about doing that is you can actually connect directly to that cloud environment, the platform as a service environment, via Management Studio and query that independently after the fact. So if we've got that scenario where you're looking at auditing and compliance, having it decoupled but parked in an environment where you can auto-scale it but then query it as well, that's quite a nice feature there.
Yeah.
That would be read-only though, right?
Yes.
It's read-only, yeah.
Yes.
Just one question about the temporal tables and joining across tables on a specific system data. Because if multiple tables change in varying things, and I want to query the state of everything on a certain date across tables,
Mhm.
do you have to actually reference the system date for each table, or you just provide it?
No.
No, you just say an as of date, and it'll go. Say you have two temporal tables. You have an employees and say, I don't know, some other table, transactions, right? Just made up two tables. And each one of those are temporal. And you say, I want to go do a join of employees to transactions on June 1st of last year. It'll go pull the temporal information, the state of those tables at that date for both of them, and then do the join as if you had traveled back in time. And that's the concept. Yeah. The idea is that you can, with temporal, the idea is that you can view the state of the system at a particular date and time or range in time. So temporals for things like trending. So how many orders did we have in the system over some period of time, but I don't have to keep all of that order history into my active OLTP tables, right? Classic CS case study, right? I've got an orders table, an order history table, right? Everybody has these things. Well, how often do you hit the orders table? And if you have something, I mean, imagine your orders table if you were, say, Amazon.com. Right? How big does that table get? How fast does it get that big? And we all know that the bigger these tables get, the slower they go. Stats management becomes a pain, index management becomes a pain, backups become a pain. And so temporal's there to offload some of that, and then using things like Stretch, you can take that temporal data and move it to the cloud. So you have cheap storage locally, very fast performance system, and you can get to the data whenever you want. It's kind of the layering of these technologies. Does that make sense?
Yeah.
Yeah.
Yeah, the scalable database in Azure, is it one node, or it can be scaled out automatically to one node?
So the question is the backing database in the cloud. Can it be scaled? Is it one node? Can it be scaled to multiple nodes? So the system, I can't remember what they're called.
Stretch
units?
database units. Yeah.
Yeah.
So it's a very similar concept to database throughput units or data warehouse units.
Yeah.
So we have a stretch database unit that allows you to scale it on that.
So it's possible to be a multiple node on each.
Yes.
It is. Yes.
Yeah.
Yeah. You can have.
Queries, if you're sending queries from a so we handle all the raising the data from different nodes and get the result.
Yeah, so essentially the system in the cloud works in a sharding methodology. So it'll take your data and say you had multiple nodes, it'll shard the data across the multiple nodes. And when you run a query like this, select star from temporal table that I just did, it'll actually run a distributed plan in the cloud, generate all the data as an aggregate, send that back down to the local machine. So, and you can do that as a change of operation in the cloud. So you can actually go from one to multiple nodes or from multiple nodes to one.
I heard some different terms regarding this area, like Azure DB, SQL warehouse, and also extractable SQL server. How do you relate to
Yeah, so the question is like, really, there's multiple kind of technologies all floating around that do this. I'll add one more. So there's a Polybase session that's later today that'll talk about a capability called Polybase, which is the ability to query from T-SQL code into a Hadoop cluster. That also has in SQL 16 a scale-out capability. So you can actually write what we call a head node or a control node that sits as your master, and you can actually build scaled-out versions of SQL sitting on-premise or running as ISVMs. When you run a distributed Polybase plan, it says, hey, go get all of my data from my local table as well as, say, all my weblog data. The use case we always use is, imagine I'm running a .com site and I have order history and I have my structured stuff, name, rank, and serial number. So name, order, all that kind of basic stuff. And I have, say, weblogs. So you could run a query that says, hey, go show me my customer who is a rewards customer who signed into my website, and what did they view? And you can start to run analytics across that. Well, that weblog traditionally would land in something like Hadoop. You can write that all in T-SQL, and Polybase will actually scale out and go to Hadoop, run a job, and pull all that data back. Well, the way to do that is in parallel. So you can actually scale out the backside of SQL. So you could have a SQL instance running as your head node, and then you can create multiple SQL instances as backing nodes to scale that operation out for performance into very large numbers. And so you can scale that technology out. So the same methodology of a single kind of head instance and multiple compute instances is pretty common now in SQL. There's quite a few places for it. Yeah.
What if you stretch the databases offline for employees?
If your stretch database is
and you
offline,
haven't disabled the stretch, and you issue a query saying select star from table.
well, if it's offline locally. I mean, it will just fail. It'll just say your database is offline and can't be accessed. So all of those same kind of operations that happen, with an offline database would still happen. You couldn't do anything.
So if you've got part of your data on premise and part of it is stretched.
Yeah, it'll still just, the controlling component of it is the local database. So if the local database is offline, the cloud from a front-end perspective in that operation would be offline. Now, to the point earlier, you could go connect to the cloud instance and actually connect and view that part of it as a read-only operation as well if it's unpaused, if it's still online. But if you have your local database offline and the cloud instance offline in paused state, then the data is completely inaccessible until you turn them back on. And you can ask questions like, I'm surprised somebody didn't ask this, what happens if something happens to my instance halfway through? Right? You get a failover incident, or you take your database offline as stretch is working. So all of this data is journal. It's transactional based. So as a row moves out of the local instance to the cloud, it's transactioned. And if it fails moving up there, say network connectivity, somebody cuts the wire in your building and you lose connectivity. All of those things are journaled. And so if it doesn't pass all the way through the transaction and moving to the cloud, it'll get rolled back, just like any other operation. And then the system will try again. It'll continue to try until it can satisfy what it's trying to do. So.
This strategy features does yours go to the Azure stack?
Sorry, say that again?
Does Straddle features go to the Azure stack or just Azure?
So the question is, when will these features come to Azure Stack?
Yeah, we may some data we don't want to publish to public cloud.
Yeah.
So suppose we have a private cloud with Azure stack. We'd like to have this feature.
Yeah, so the way the Azure Stack system works is it's built on the cloud services, so it's built on Azure SQL DB. It's not using, it's built on that stack of code instead of, say, just SQL instances. And so as these features become available in SQL DB, then those will transition into being available in Azure Stack as the services move into being supported. Does that make sense?
So you think this will be supported with Azure stack?
Well, when SQL DB gets supported there, whatever SQL DB supports at the time, it's kind of a two-hop operation. One, stretch would have to be enabled in SQL DB itself, and then SQL DB has to get supported in Azure Stack. It's kind of those two hops to make this work on Azure Stack. So, yeah.
Is there a performance hit if your query doesn't touch the stretch data?
No. So it runs all local. So the query engine it's a cost-based optimizer, and it looks at its cardinality and says, okay, well, all of my rows are local, so it doesn't even consider going to the cloud based on any predicates. So we could run any one of these queries that we have set up and say, just hit the rows that we know are local, and it'll interact just like you would with SQL, just local. And this is the premise of the idea, is that generally the idea is to offload all this additional work and all this additional read I/O that you would do. Even if you have things like partitions we were talking about earlier, partition elimination, if you were running, SQL 16 has this concept of, I can't remember the name of it, I know the code names. You have the ability of creating row store indexes, which you would traditionally do with an order history table, and then we have this operational analytics.
Column stores, yeah.
Yeah, you can create, it's called operational analytics, where you can actually overlay a custom column store index on top of a row store based index. So you could do real-time analytics in a data warehousing kind of model on a row store based index. So you can do both. The idea is that you could take any one of those operations and offload the bigger operations and try to keep your table as small as possible. So you get fast index rebuild times, you get very quick performance for things that are hot data, things that you would interact with very quickly. So a list of customers, so you would want to interact with that fairly fast, so you'd keep that as hot data. Cold data, hey, maybe customers who don't, or who haven't signed in or bought a ticket from us in 5 years, that would move to the cloud because you're not going to interact with it very often. So SQL optimizes for that local hot data. So kind of a long answer to your question. Okay. All right, any more questions about kind of this scenario? Yeah.
Is it transparent to third-party backup?
Yeah. So if you run a backup against this database, you can mark the database for, you have to correct me where I get this wrong. You can mark the database for a full backup to pull all of the data down if you need to. The idea is that generally you don't need to. Most ways I've seen people do this when they started to implement Stretch is they'll take incrementals locally, and then like third-party backup systems just use the local incrementals. Or if they're using something like disk level snapshot replication of their backups, they'll just take the local snaps and then let the cloud service do what it does.
So as long as the third-party backup solution supports or it integrates with the SQL VDI for backups and restores, then it would be completely kind of seamless with that backup and restore. If it's another backup and restore mechanism that doesn't integrate with SQL VDI, then we couldn't guarantee how it's going to handle that.
Yeah, if it's something like disk level, like if you're taking a SAN-based level snap of just the disks themselves, that becomes a whole different set of problems. So, but generally things that interact, like all the backup solutions I know where you can go back up directly against SQL on their own. Oop, that's my machine dying. They generally work through the standard SQL APIs and will work directly through this. So again, the premise behind these features is that they're presented in a way that the language surface doesn't change, the functionality surface doesn't change. This is kind of a behind-the-scenes engine operation, so that applications don't have to change. Like the biggest thing we could have done to make this feature not viable is make you have to go change all your applications. And so we didn't do that because it makes it easier for the engine to go just operationalize all this under the covers. Okay. All right. Any more questions on Stretch SQL? I know I went off the track here a little bit and gave you always encrypted and some other capabilities. So really the idea behind this is that from a SQL perspective, you think about all of the capabilities that you want to use, and then there's this kind of hybrid move. How do you get cheap storage, right? It's not on-premise anymore. It's moving to the cloud. How do you enable your local systems to not have to be able to pick up and be moved to the cloud to take advantage of this stuff? And it's capabilities like this. It's really being able to take your operational systems and kind of move them into these hybrid environments without all the cumbersomeness of, I remember tape drives and making sure that the tape drives got it. Hey, did we sure we got those things off premise? Are we sure we're going to be able to restore them? Did somebody try one of these things recently? Like all of those operations, it just becomes an automated operation. And you're then backed by the Azure cloud. It's available in 30 plus regions at this point. It's pretty much a worldwide kind of capable region cloud service. It gives you all of the capabilities with automation in the cloud. So this all connects to PaaS services. So you don't have to worry about, okay, I got to build operation and maintenance plans locally. I got to go deal with them in the cloud. It just happens for you. So you can take a lot of operational workload off of your system. So.
Okay. I'll just switch back to this.
There you go.
So a couple of go-to-dos in terms of actions from here. So I'd suggest if you've already got SQL Server 2016 in your environment today, make sure you're on Service Pack 1 and have a play with this capability. And you can use an MSDN 30-day trial subscription to have a play at setting some of these things up. If your organization already has an Azure subscription, then certainly have a look at using the advisor to assess what tables could be good candidates for Stretch. And again, just have us start to play with some of this technology, and we're just going to continue to evolve this piece. The other bit that I've been asked to just quickly talk about is evals. So please provide some feedback on this session. And also, I didn't know this until I saw this slide, but apparently you can have a chance to win a drone. So that's kind of cool. So. Thank you very much for the session today. Thank you very much for coming to this, especially given that it was kind of first thing in the morning on a Thursday. Appreciate you being here. Great questions. And we're going to be here for a few minutes after the session as well. So if you wanted to come up and ask us any more questions, please do so. All right. Thank you.